So let's just focus on redefining a function. So let's try to redefine these functions which you have here, and then after redefining we should also try to sketch them. So let's start with the first question. So redefining a function is something which is very simple and straightforward as long as you follow the simple principle and steps which I'm going to give you right now. So let's start with the basic, or let's start with the parent function. If you have got f of x as the modulus of x, how do you define this? We know that if we have got x in the modulus is plus or minus, and definitely when we're talking about plus, okay, plus is the same as greater than or equal to. Okay, we are saying if it's greater than or equal to, it's maybe we can say starting from 0 all the way to positive infinity. But if it's negative, meaning it's just less than, not less than or equal to, no, but just less than. Now if you are trying to define the modulus of x, okay, meaning that you multiply it by a positive. The one you are going to multiply it by a positive for x has to be greater than or equal to 0. Then you multiply it again by negative. The one you are multiplying by negative for x has to be less than 0. Meaning that the overall now when I'm redefining this is going to be x, the condition that x should be greater than 0, greater than or equal to 0. Then negative x, the condition that x should be less than 0. Meaning that I've redefined this to be what? To be that. That's all. Okay? But now, in a case where we have this type of question, so let's start with the first one. So we are trying to redefine. Now we can't redefine these two because we have got plus in between. So we can't redefine we can't combine them. We need to redefine x minus 6 on its own, x plus 1 on its own. So what I mean is, so I'm going to start x minus 6 in the modulus. I'm trying to redefine. So I'll put this. Now I know that what is in the modulus here, just get the way it is. First you multiply it by positive. So if I multiply that by positive, I'll just end up having x minus 6. Then the condition is that the same one which is in the modulus, x minus 6, should be greater than or equal to 0 because I've multiplied this by positive. When I multiply it by negative, I put them in brackets, then the condition that x minus 6 should be less than 0. Okay? Now, when I do this, I need to find the value of x here. And I know that what I have there is x minus 6 same as equal to, I can say it's the same as equal to 0. Okay? Or to make things simple, greater than or equal to 0. So if I shift 6 to the other side, x will be greater than or equal to 6. Meaning that the next step here is going to be, if I multiply positive by everything inside, it's going to be x minus 6, the condition that x is greater than or equal to 6. The second one, if I multiply by negative, it's going to be negative times x is negative x. Negative times positive x, or positive 6 is positive 6. The condition should be x is now less than 6. I've redefined this to be equal to that. Okay, so let me just put it here. I've redefined 1 minus 6 to be equal to, okay, that is x, not 1, sorry. So x minus 6 to be equal to, I've redefined it to be equal to x minus 6, comma, x is greater than or equal to 6. Then negative x plus 6, the condition that x should be less than 6. I've redefined it. Now let's also go ahead and redefine the second one, which is x plus 1. So I'll say x plus 1, redefining that, we follow the same principle. So first I need to multiply by positive. X plus 1, the condition that x plus 1, if I multiply by positive, is greater than or equal to 0. Then I multiply by negative, x plus 1. The condition should be the same one but less than 0. Then we solve for x. So if I solve for x, here you clearly see that we have x, okay, we have x minus plus 1 greater than or equal to 0. If I solve for x, x will be greater than or equal to neg 1, meaning that even the down part is going to be x is less than neg 1. So if I continue this from here, we can clearly see that we are going to have, if I multiply positive here by everything, nothing is going to be affected inside, so I'll have x plus 1. The condition that x is now greater than or equal to neg 1. Then here, if I multiply by negative, it will be negative x minus 1. The condition that x is less than neg 1. I've redefined now this one as well. So now, allow me to put this one just here. Okay, I will just put it here to make things simple. So I've redefined x plus 1 to be equal to x plus 1, the condition that x is greater than or equal to neg 1, neg x minus 1, the condition that x is less than neg 1. I've redefined it now. After doing that, since there is plus, we are adding these two things. The only thing which I can do is I need to use a table. So I'm going to use my table. So here is my table which I'm going to use. Now this table, I want you guys to understand what's happening here. So initially what is happening here is we have two values. Okay, we have two values which we have found. We are dealing with neg 1 and 1. Okay, so we are dealing with neg 1 and 1. So what we're going to do now is I'm going to put these values on the table. So we know that neg 1 is let me just get rid of these two lines here down. Okay, we have neg 1 and 6, so I'll put neg 1 here, then 6 there. Now one thing we need to understand here is this: we are dealing with the greater than and the less than. So the numbers which are coming from negative 1 going all the way this side is less than negative 1, meaning we are following this condition here. So here I'm going to say x is less than what? Negative 1, meaning I'm done with this part here. Let me just put here x should be less than neg 1. This neg 1. So for this one, we have used it. Next, here we have got x, 6. Numbers from 6 going this side is greater than 6, meaning that we are dealing with x is greater than or equal to 6. So I'll say, if I want, I can just say x is greater than or equal to 6, or it's the same as I just put it like this. What I mean 6 is less than or equal to x, it's the same as x is greater than or equal to 6. It's the same thing. Okay, so when I do this, in between here now, this one I've used it, I'm remaining with this guy and that guy. Okay, so we know that in between here, for the one for one we are remaining with is x is greater than or equal to, meaning that I need to say greater than or equal to x. Negative 1 is less than or equal to x, which is the same as negative 1 less than or equal to x, same as x greater than or equal to neg 1. Okay, so you are not supposed to be confused here. So we have used now what? We have used this guy. We are remaining with 1. The next thing, we go to 6. So 6 is less than, then I need just to say x is less than 6, meaning I've also used this guy. Now when I do this, I need now to use the guys which I know what in modulus. Okay, so I'll start with the first one, which is x minus 6. So x minus 6, we are dealing with this part here. So we are saying that the first box is x is less than negative 1. In the first box, if I go here, which one is telling me that x should be less than -1? I can clearly see that the one which is talking about the less than is the second one, meaning I'm going to put x minus or plus 6. I'm done. I go to the next one. The next one we are dealing with is telling us that -1, x is greater than -1 but should be less than 6. Okay, meaning we are still dealing with the same one, because this is saying that x should be less than 6. But again, if x is less than 6, it can be greater than -1 but less than 6, so I'll still get that. Finally, x is greater than or equal to 6. We know that we are going to get the first one. I'm done for the first part. Then I move to the second one, which is x minus plus 1. So for the first part, which one is telling us we are now here? Which one from this line here, which one is telling us that x is less than -1? It is the second one, which is -x minus 1. We jump, we go to here. Which one is telling us that x is greater than -1 but less than 6? But initially we don't have less than 6, so we're talking about greater than 1, which is the first one, x plus 1. Then which one is also telling us that x is greater than 6? Is again the first one, x plus 1. When you do this, meaning there is plus here, we are following this sign here in between. If there is minus, we're going to do minus. If there is plus, you're going to do plus. So now there is minus. So what we're going to do is we need to add. Let me just push this one a bit on top there. And then I get rid of this. So we need to add this plus that, this plus this, that plus that. Then the conditions, that's why it's very important for you to focus on these. These conditions are very, very, very important. So I'll say x, I'll put it here, x minus 6 in the modulus plus x plus 1 in the modulus should be equal to, I'll start with the first part. We are saying -x plus 6, again plus, we're following this sign here, then plus what we have here down, again -x minus 1. What is the condition? The condition for this box is that x should be less than -1. X is less than -1. Done. In between we have got x plus 6 plus x plus 1. The condition is that -1 less than or equal to x and x less than 6. Done. We move. So we have the last one, which is this. We add those two. We have x minus 6 plus x plus 1. The condition is that x is greater than or equal to 6. Then we add. So if I add x and this one, is going to give me -2x. 6 minus that one is going to give me plus 5. Perfect. What is the condition? The condition that x should be less than -1. We go to the next one. X and x will cancel. 6 plus that one is 7. What's the condition? The condition is that -1 less than or equal to x less than 6. The next one, x plus x is 2x. -6 plus that one should be -5. What is the condition? The condition that x should be greater than or equal to 6. So if the question is just asking you to redefine this function, this is the answer, the final answer. So we have redefined this function. Now after redefining this function, you need now, in a case where you are going to be given, let me give an example. For example, let's say we have f of x is equal to x minus 6. They just ask you redefine. That's the answer. It ends there. They just ask you this part only to define. That's the answer. Like the way it is, the combination of this and that one, the answer is this one. Okay, so we have been told to redefine and sketch. So we have redefined. Now let's try to sketch. Sketching this is something which is very simple. As long as you know how to sketch piecewise function, I believe this is going to be simple for you. So let's try to sketch now. So I'll need first to come up with the to my simple coordinate. I'll start with the first one. You know, this is sketching. This type of graph is very simple because you have the domain already. So we are saying that x should be less than -1, meaning -1 going all the way to negative infinity. I'm going just to get two coordinate, -1 and what? I'll get -1 and -2. So let's see. If we put -1 where there's x here, it's going to be -1 times -2 is +2. +2 plus 5 is 7. But remember, it is less than. At this point, it's going to be open. If I put 2 times -2 times -2, 4. 4 plus that is 9. I'm done. Next coordinate is going to be in between. In between here, we have been told that it's just -6 all the way. I can just put -1 here and then 6. We know that it's going to be, when we put -1, we have just 7. We have just 7. We don't have any value of x. If we put 6, it's 7 again. We are done. But at this point, it has to be included, but at that point, it has to be open. The last one is the third one here. So we start with 6. If I put 6, it's going to be 2 times 6 is 12. 12 minus 5 should be 7. Okay, is greater than or equal to, it will be included at that point. Another point, I'll just get 7. 7 times is 14, so I'll get a 9. Then now I can sketch. I can now sketch. So in x, we expect to have -1, -2. In y, do we have positive? Yes, we have 6. And then in y and also 7. Let's just say 6 here, 7. So in y, the values which you have, I've got 7 and 9. That's all. So I'll just put here 7, 9. So the first coordinate is negative. In fact, let me start with the one in between here, which is -1, 7. -1, 7 is here included. Then 6, 7. 6, 7 is here not included. So I put a line there. Then I'm done with this. I can go to that one. -1, 7 open. It is open at that point. Next we have what? We have -2, 9, which is here. So I can clearly see that my graph is going there. You put an arrow, we don't know where the graph is ending. Here we have 6, 7 included, so I'll put it inside there. Included. 9, 7 again is here. We don't know where the graph is going, is ending, so I need to put an arrow as well. So I have redefined as this one. I have also sketched. So you say that's the graph of f of x is equal to the modulus of x minus 6 plus the modulus of x plus 1. Like that, as simple as that. What I've done here, you do the same thing to solve part C. It's definitely the same thing. Okay, so I'm going to do part B. Again, if I do part B, that will be the same thing you can do also. You follow the same principle. I want you to go ahead and solve part C and D, then you send me the solutions. Okay, if you have the chance to send me the solutions, you'll be able to send me the solutions, or you can just leave the answers in the comment section. I'll be able to see them. So let's go to part B. So part B, we are trying to redefine as well. Let's go ahead and see. So we redefine the first one. So to redefine this, we know that for the first part we multiply by positive 2x minus 1. The condition is that 2x minus 1 should be greater than or equal to 0. Next, I multiply by negative 2x minus 1. The condition that 2x minus 1 less than 0. Let's go ahead and finish it from there. So this one, the positive will not affect anything. Now let's solve for x. So we solve for x, we'll have 2x minus 1 greater than or equal to 0. 2x is greater than or equal to 1 divided by 2, 2x is greater than or equal to half. So the condition now is that x is greater than or equal to half. So for the second part, it's going to be negative, or negative times 2 is going to be negative 2, then it will be plus. Again, we still have the same condition. So I've redefined the first part, of which I'm going to put it here. I'll put it there. So we have 2x minus 1 for x is greater than or equal to half. Then negative 2x plus 1 for x is less than half. Done. I've redefined the first part. Now let's go ahead and redefine the second part. So the second part is x plus 2. We know that for positive x plus 2, the condition that x plus 2 should be greater than or equal to 0. If we multiply by negative, the condition will be that x plus 2 is going to be less than 0. Let's solve for x. So x plus 2 greater than or equal to 0. Shift 2 to the other side, x will be greater than or equal to negative 2. So we finish it from here. We can clearly see that positive will not affect anything. So if I multiply by positive, it will be x plus 2. The condition that x should be greater than or equal to negative 2. Then the next one will be negative 2, negative x, minus 2. The condition should be x is less than negative 2. I've redefined that one, of which I'm going to put it here. Okay, let me just put this part there, then this part here. Okay, now we can also, now there is minus there, so we still use the table to find the values. Let's see. So I'll have the table here. Okay, can you put it there? Another one here, another one there. Or let me put this table here so that I have space this side. I'm going to use it. Okay. Okay. So I have 2, so I need to do this. That's all. So what values are we dealing with? We're dealing with 1 over 2 and negative 2. So I'll put negative 2 here and 1 over 2 here. Now, the numbers from negative 2 going this side, they are less than negative 2. So meaning that x is less than negative 2. We are done with the first part here. So we have used this. Then the numbers from here going to this side is greater than. Which one do we have greater than? Is this guy, the first part, but is what? So I'll put this. Like I said, 1 over 2 less than or equal to x is the same as x is greater than or equal to half. It's the same thing. You can clearly see that the open side is where the x is. So it's the same thing. So I've not changed anything there. In between here, so I've used this, I've used that. We are remaining with 2. In between now, talking about 2 is greater than x. So I'll say less than or equal to x, but again less than half. So this one less than negative 2 is less than or equal to x. It's the same as x is greater than or equal to negative 2. Then x is less than half. It's just dialect here. So I've used everything now. So when I do that now, I need to start now putting this. I'll start with 2x minus 1 in the modulus. Okay. So if I put, for the first part here, which one is telling us that x is less than negative 2? The one which is telling us that x is less than negative 2 is the second one. Because the second one is saying that x is less than half, meaning that I'm going to get negative 2x plus 1. Again, for the second, for the same one, which one is telling us that, since we are dealing with half, which one is telling us that x is less than half? So it's the same one, negative 2x plus 1. Then for the last one, which one is telling us that x is greater than or equal to half? It's the first one here. So I'll get 2x minus 1. I'm done. I go to the second one, the modulus of x plus 2. Which one is telling me that x is less than negative 2 for the second one? It's this one. So I'll put negative x minus 2. Then here we are dealing with 2, so I'll concentrate on 2. Which one is telling us that x is greater than or equal to negative 2? It's the second one. So I'll put x plus 2. The second one is, which one is telling me that x is greater than half? It's the same, the same second one. I'll use it there. When I do that now, since there is minus, I need to add these things. I need to subtract, not adding, because there is minus. So I'm going to say this minus that. So I'll say negative 2x plus 1. I put them in the brackets, minus negative x by minus 2, like that. So what is the condition? The condition is that x is less than negative 2. Okay. On the middle here, in the middle here, we have negative 2x in the brackets plus 1 minus in the brackets x plus 2. I'm just getting this and that. Now what is the condition? The condition that negative 2 is less than or equal to x and x is less than half. Done. Let's go to the last one. In the brackets x plus or x minus 2 minus 1, sorry, then we have got also x plus 2. What is the condition? X should be greater than or equal to half. Done. Now I need to add now, finding the final answer. So it's going to be now, it's like I have, let me just rewrite this. I want to open the bracket now. I have got negative 2, I want that negative to be visible, negative 2x plus 1. So this negative and this is going to be plus x plus 2. The condition that x is less than negative 2. This negative and that will be positive. Even there it will be positive. That's what we should know. Then here I also open the brackets. So it will be negative x minus 2. The condition that negative 2 less than or equal to x less than half. Next, I'll also open the brackets. So here it will be minus this minus 2. This and that negative, this and that negative. The condition that x is greater than or equal to half. Okay, let's finish it from the top part here. So our final answer when we redefine will be this and this will give me negative x. This and this will give me plus 3. Okay? The condition x less than or equal to, or is just less than negative 2. So here we can clearly say that negative 2x and this is going to give me negative 3x. Then this and that will give me negative 1. Okay? The condition is that negative 2 less than or equal to, okay, negative 2 less than or equal to x, and then less than half. Then for this one, it's going to be this guy and that one will give me positive x. Okay, positive x, then negative 1 and that one will give me negative 3. Let me write it properly. Will give me negative 3. So the condition is that x should be greater than or equal to half. Okay. So here initially I want just us to be sure on the one in on the middle here. So we are saying this and that. If we do minus, okay, yeah, it's giving us the correct thing. So let's see what we're going to have. Let's create space. We create space, we see what we're going to have. So we are trying now to sketch. We are trying to sketch. So we create space on top there so that we see how we can sketch this. Okay, so let's see. So now when the issue of redefining this one alone, I have redefined, this is the final answer for redefining. That's the final answer for redefining, but we are trying to sketch it. So let me get rid of everything here. So sketching, let's first come up with the coordinate. Like I said, I'm going to come up with coordinate this side for the first part here. So if x is negative 2, but at that point it's going to be included. Even if you don't show that it's included, it's okay. You just put the lines. It's alright. If I put negative 2 here, it's going to be positive. Okay? It's going to be positive 2. Positive 2 plus 3 is 5. Okay? If I put negative is less than negative 1, let's put negative 1. If I put negative 1, it's going to be what? If I put negative 1 times this one is going to be positive 1. So it's going to give me 4. If I put 0, it's going to give me 3. I end there. In between, we have been told that the values of x should be in between negative 2, neg 1, 0, and half. Just like that. So if x is negative 2, let's see. If x is negative 2, negative 2 times this one is positive 6. Positive 6 minus this is 5. But at that point is included. Okay? Then negative 1, if it's negative 1, but initially the best thing what we can do without us, I don't want us to waste time. I can just go direct to half because I need just to connect the line which is going to be negative 2,5 and the 1 over 2. So if I put 1 over 2, times neg 3 is going to be neg 3 over 2 minus 1, of which is the same as I put 2 over 2, so negative 5 over 2. So it's going to be negative 5 over 2, like that. In between here, if you want, just ignore, because you are going just to connect the line. Then the next one will be, if I put half, what do we expect? We have x minus 3. So half minus 3. Half minus 3 is the same as, we say, 1 over 2 minus 6 over 2, like that. Because 6 over 2 is negative 3, like that. So meaning this is going to be negative 5 over 2 as well. Negative 5 over 2 again. Then I need to have another coordinate. Let's just get 1. If I put 1 minus this is going to be negative 2. I end there. If I want, I can put 3. 2. 2 minus that, neg 1. Not so. Yeah, neg 1. So we have, so from here now I can sketch according to what I have here. I can now have my graph. How do we expect our graph to be? Here. So we have the x values. Allow me to put this one just to be there. Okay. The x values, we've got negative 1, negative 2. Okay. So the negative part, we have neg 1, neg 2. The positive part, we have got 1 over 2, 1, 2. 1 over 2, 1, 2. Then the y, we have got 3, 4, 5. Then the negative side, we have got only negative 5 over 2. That's all. Oh no, we have negative 5 over 2. Let's not forget this. We have neg 1, neg 2, and negative 5 over 2. Okay. Then the positive part, we have 5. We have 3, 4, 5. 3, 4, 5. 3, 4, 5. So if we are to sketch, let's start with the one in between, because that one requires us to put a line. Negative 2, 5. Negative 2, 5 is here. Where is it? Negative 2, 5 is there. Then negative 5, 2. Negative 5 is here, 2. 2 is there. Okay, so before I put the line, I want us first to do 1 over 2, 1 over 2, 5. Again, it's the same point. 1 over 2, no, it's here. 1 over 2, 5. 1 over 2. So we are starting with the first part. No, this one we are saying is 1 over 2, 1. This one is negative 2, 5. That point is correct. Then negative half, negative 5 over 2 is here. Half, negative 5 over 2. It should be here. Yes. That's now perfect. Not this point. Okay. Not that point, no. Another one, we have, so can I have a line there before I even connect the line? Let me first do negative 2, 5. Negative 2, 5 again is that one. Then we are saying negative 1, 4. Negative 1 is here, 4 is there. Okay, that will be better, I think. Next we have 0, 3. 0, 3 is somewhere here. In x 0, in y there. Okay. It's now making sense. Okay, so and then what else do we have? What else do we have? So we have 1 over 2. Where is 1 over 2? 1 over 2 comma 5 negative 5 over 2. 1 over 2 is here, comma negative 5, which is here. Okay, then 1 in x1 in y negative 1. Okay, that is that point. In y negative 2. So x1 in y negative 2 is this point. Let me get rid of this. Is that point? Okay, another point is 2 comma negative 1. So 2 comma negative 1, which is there. So now this graph, the way it's going to be, is like this. Let me show you. From this point here, it's going direct, just straight there. You put an arrow, we don't know where it's ending. Then from here, it comes like this. It comes here. When it reaches there, it has to turn. Okay, when it reaches there, we have this point is supposed to be somewhere here. 4 negative 1 is here. Then it has to come like this. Then it comes from here. Now the line has to come like this. What I mean here is this. There is a point in between here, I might forget, but this is how the graph is supposed to come like. So here you put an arrow, we don't know where it's ending. So now this graph, the way it is, initially only that it's looking more as if the shape is not making sense, but initially it was supposed to be like it comes there, it comes there a bit, then it goes like that. But it's the same thing anyway. It's just sketching. No one is going to penalize you. So if you do your math correctly here, we are supposed to get a perfect graph. Okay, for example, here if we are to put, where is it? Yeah, the one in between. Here, if I'm to follow this one correctly, if I put negative 1 here, it's going to be negative 1, which is going to be positive. So which is going to be 2 minus 1. What is 2 minus 1? It's 1. So it was supposed to be to go at 1 comma 1. Okay, which we have it already. So if when I have got 0, it's going to be at negative 1. Negative, so at 0, then negative 1 again here. That's why I said it was supposed to touch this line, this point here. Or let me just do this before we go there. I want to redo the points. Just a minute. We'll do the points. So what I mean, guys, is this. We started with, let me start from here. We started with this. I said that here is we have got negative 2. Let's just get 2 points. Negative 2 and negative what? Negative 3. Because these are numbers which are less than negative 2. If I put negative 2 here, it will be 2, 5. If I put negative 3 here, it's going to be 6. Okay? And then if I put, yes, it's going to be 6. So that's where I made a mistake, where I was saying it was negative 3 comma 0. No. So now the other one in between here, if I put the numbers negative 2, neg 1, 0, half. If I put negative 2 here, it's going to be 6. 6 minus this is 5. If I put negative 1 is 3, 3 minus 1 is 2. If I put 0, it's going to give me negative 1. If I put half, okay, if I put half, what are we going to have? It's like negative 3 times half, then minus 1, which is the same as negative 3 over 2 minus 1. 1 here is same as 2 over 2, so it's going to be negative 5 over 2. So you'll have negative 5 over 2. The last one, if I put half, I'll just put two numbers and 1. If I put half, 1 over 2 minus 3, it is the same as I say 2 over 2. 2 over 2 is 1. 1 times this, 3 is 3. Meaning, I have got 6, negative 5 over 2. So it will start negative 5 over 2. Then, if I put 1, 1 minus that is going to be negative 2. Not so. 1 minus that, negative 2. So if I plot this now, we are saying, let me just redo it here. We are saying that negative 2 comma 5, negative 2 is here, comma 5, 5 is there. Okay. Then negative 3 comma 6, negative 3 comma 6 is negative 3 here. If I put negative 3, then comma what? 6, of which 6 it can be somewhere here. Let me put 6 here. So negative 3 comma 6, it will be there. Initially this graph, this line, it will go like that. We don't know where it's ending. Yeah, this is now going to be perfect. You put an arrow. This arrow shows that we don't know where the graph is ending, because we can keep on going, negative 4, negative 5. Next one, negative 2 comma 5. Negative 2 comma 5 again is the same point. Then negative 1 comma 2. Negative 1 is there. 2, it can be here. We can put 2 somewhere here. Then 0 comma negative 1 is here. Oh, in x 0, in y negative 1 is here. Okay. Then half comma negative 5. Half comma negative 5 is here. Again here I need to put a line. Now this is perfect graph. Yeah, it comes like that. Then another one will be half, which is again the same point, then 1 comma negative 2. 1 is there, negative 2 is here. So this one will also go in this direction. We go there, it goes like that. So you put again an arrow, showing that we don't know where the graph is ending. Yeah, so this is now perfect. So this graph which I've given you now is the perfect graph for that function. Now, you can clearly see that the part A and part C, they are the same. Follow the same principle, solve part C. Part B and D, they are the same. Follow the same principle, do part D, and send me the solutions.